Exercise 5.1, question number 3. Determine whether the following quadratic equation have real roots, and if so, find the roots by using quadratic formula. We are going to determine whether it has real roots or not, and if it has real root, the root will be found out by using the quadratic formula. So this is the way it should be done. Firstly, we need to check whether it has real roots or not. So to check whether real roots, b square minus the discriminant b square minus 4ac should be greater than or equals to 0. So I'll write that down. A quadratic equation has real roots if b square minus 4ac is greater than or equals to 0. If it is greater than or equals to 0, it has real root. Otherwise, it will not have real roots. If b square minus 4ac is less than 0, no real roots. Less than 0 means that the value become negative. So let us check this one. The discriminant b square minus 4ac. We will check this value. B value is minus 5 root 3. Minus 5 root 3 whole square. Minus 4. A value is 1 here. Nothing is written, so it is 1. Minus, 4a. C value is equals to 18. So we have to solve this one. 5 square is equals to 25. 25 into 3 is equals to 75. Minus, multiply this. 4 8 are 32. 4 1 is 4, 72. 75 minus 72 is equals to 3 only. So this 3 value is greater than 0. So therefore, b square minus 4ac is greater. The value is greater than or equals to 0. It has real root. So if the value of b square minus 4ac, if it happens to be minus 3, it will have no real root. But since it is greater than 0, it has real root. So if it is like this, we have to find out the solutions, the roots by using quadratic formula. So now, this is quadratic formula. X is equals to minus b plus or minus root over b square minus 4ac by 2a. This formula is called quadratic formula. This is minus b value is equals to minus 5 root 3. So we put minus b value is minus 5 root 3 plus or minus b square minus 4ac value is already calculated, it is 3. So I'm writing 3 there by 2. The value of a is 1. So I put 1 there. This implies, you should remember that this is a value, this is b, and this is c. Then we have minus become plus. 5 root 3 plus or minus root 3 by 2. Then either, these are the two roots, either x value equals to 5 root 3 plus root 3 by 2, or x value should be equals to 5 root 3 minus root 3 by 2, giving us 5 root 3 plus root 3 is 6 root 3 by 2, or x value is equals to 5 root 3 minus 3 root 3 is equals to 4 root 3 by 2. Cancel this one, it becomes 3 root 3, or x is equals to 2 root 3. So I'm going to conclude like this. The two roots of the given quadratic equations are, since I have no more space, let me write down here. Therefore, 3 root 3 and 2 root 3 are the roots of the given quadratic equations. So just like that, we'll be solving this one. After solving, we find out that b squared minus 4ac is less than 0, so it has no real roots. Let us come to question number 4. In question number 4, it is like this. A quadratic equation ax squared plus bx plus 0 has real and equal roots if b squared minus 4ac is equals to 0. We will calculate, and if b squared minus 4ac is equals to 0, it has real roots, real and equal roots. If rational and unequal root if b squared minus 4ac is greater than 0, and b squared minus 4ac, if it is a perfect square, it will become rational and equal roots. Irrational and unequal root will be obtained when b squared minus 4ac is greater than 0 and b squared minus 4ac is non-perfect square number. The value should be non-perfect square. And no real root if b squared minus 4ac is less than 0. So we're asked to determine the natures of the roots of the quadratic equations in question number 4. Without solving, examine the nature of the roots of the quadratic equations. We are going to examine the natures of the roots of the quadratic equations. So I'm going to take question number 3, 25x squared minus 25x plus 6 equals to 0. We are going to determine whether it has, we are going to determine the type of root it has. So firstly, we calculate the discriminant b squared minus 4ac. B value is minus 25 minus 4ac. 4ac, 4 value, a value is 25. Here a is 25 and c value is equal to 6. After calculating this, we get 25. 25 is a perfect square number and it is greater than 0. So if you look at this here, 25 is greater than 0 and 25 is a perfect square number. So it will have rational and unequal roots. So we control like this, which is a rational number and a perfect square number. Therefore, the given quadratic equation has rational and unequal roots. Then, coming to question number 5, we are asked to find out the sum and the product of the roots in question number 5. Sum and product of the root. To find out the sum of the root, the formula is minus b by a. B is the coefficient of x and a is the coefficient of x squared. Product of the roots should be c by a. C is the constant term and a is the coefficient of x squared. So following this, we solve question number 5, the problem like this. Sum of the root. In question number 5, Roman number 3, sum of the root is equal to minus b by a. B value is minus 3 root 3. This is b value. So we write minus is the formula. B value is minus 3 root 3 by a. A value is 2 here. So minus b by a value becomes like this. The roots minus become plus. So sum of the root becomes 3 root 3 by 2. Product of the root is c by a. What is the value of c here? 3 is the value of c and a value is equals to 2. So product of the root become 3 by 2. Likewise, I will not explain this one. You have to copy down this. Then let us come to question number 6. Form a quadratic equations when the roots are given. This is already solved one. You have to copy down by yourself. Let me take this problem. Firstly, we are given the two roots, 3 plus root 5 and 3 minus root 5. These are the two given roots. We are going to form a quadratic equation based on this. So this is the solution. Firstly, let me write down sum of roots. Sum of the roots will be equals to 3 plus root 5 plus 3 minus root 5. We will find out the sum of the roots. This is equals to, open the bracket and it will become 6. After opening the bracket, it will become 6 and product of roots. Product of roots will be 3 plus root 5 into 3 minus root 5. It is of the form a plus b, a minus b, so it becomes a square minus b square. It becomes 9 minus 5, which becomes 4. Product of the root is 4, sum of the root is equal to 6. Now, formation of quadratic equation is x square minus sum of the root into x, sum of roots into x plus product of roots equals to 0. This implies that x squared minus sum of the root is equals to 6 into x plus product of the root is 4 equals to 0. Therefore, the required quadratic equation is x squared minus 6x plus 4 equals to 0. These are the homework that you are supposed to solve it. Keep in your notebook. I will tell you when to submit.